Hey, welcome to Deep Signals. So today, we're going to take a trip to a world that's actually hiding right in plain sight. You know, it's that small, fast-moving planet you can sometimes catch right after sunset or just before sunrise. Named, of course, after a swift messenger. We are talking about Mercury.
You know, when you look up and see that little bright dot zipping across the sky, it's so easy to just think, oh, another star. But it's not. It is a whole world of scars and surprises, and today we're going to explore what makes it so incredibly fascinating. So Morgan, are you ready to head out to the solar system's innermost planet?
Oh, absolutely, Alex. It's funny, right? It's a place we can literally see but almost never really think about. Let's get into it.
All right, so our first stop, we really need to get a feel for just how strange Mercury is. I mean, this is a place that's just defined by these mind-bending contrasts. Numbers that honestly don't seem like they should make any sense at all when you first hear them.
Okay, so the very first thing you have to try and wrap your head around is time itself on this planet. On Mercury, a single day, we're talking from one sunrise to the next, lasts for 176 of our Earth days. But get this, its year, the time it takes to make one trip around the sun, is only 88 Earth days.
Hold on, wait, let me get this straight. You're saying a single day on Mercury is literally twice as long as its entire year? How does that even work?
Well, it's this really weird result of its super slow rotation and its really fast orbit. But, time isn't the only extreme thing here. Just look at these temperatures. In direct sunlight, Mercury's surface can get up to 430 degrees Celsius. I mean, that's hot enough to melt lead. But then in the shadows, it plunges all the way down to a freezing minus 180 Celsius.
Wow, that is an unbelievable swing. You're going from a pizza oven to a deep freezer in an instant. It really just goes to show how much work our own atmosphere does for us, right? Here on Earth, our weather systems are constantly moving heat around, stopping those kinds of drastic changes. So, what is going on with Mercury? Why is it so extreme?
And that is the absolute key. The reason is that Mercury has, well, it has pretty much no atmosphere. You can think of an atmosphere like a blanket, right? It traps heat and spreads it around the planet. Earth, we've got a nice thick blanket. Mercury, it's got basically no blanket at all. So whatever side is facing the sun just gets completely baked, and the side in darkness, it just radiates all its heat straight out into space.
Okay, so now that we've got a feel for the lovely environment, let's actually go down and take a look around. Just imagine for a second you're standing on the surface. What you'd be seeing is this ancient, rugged landscape that tells a really, really violent story.
The ground itself is like a history book written in impacts. I mean, you've got craters just everywhere, from tiny little pockmarks to these massive basins that are as wide as entire countries. In between all those craters, you'd see these huge, smooth plains, which are really just ancient lava flows that cooled down a long, long time ago. But then, if you look a little closer, you start to spot these weird, bright pits. They call them hollows. And maybe the most surprising thing of all? Tucked away in the permanent shadows of craters near the poles, scientists have found something you would never, ever expect here. Water ice. Real, actual water ice. Wait, ice? On a planet that hot? That is incredible. But you also mentioned those hollows. That sounds really strange. What exactly are they? I mean, what do scientists even know about them?
So this is one of the most exciting mysteries about Mercury right now. The leading theory is that there are certain materials inside the rock, stuff that turns into gas really easily when it gets hot, and they're basically being cooked by that intense sunlight. As those gases escape into space, the ground that's left behind kind of crumbles and collapses, creating these bright, shallow pits. It's a huge clue that the planet might still be geologically active, like it could be changing right before our very eyes.
Yeah, this active surface is absolutely fascinating. But to really understand what makes Mercury tick, we have to go deeper. Because beneath that rocky crust and mantle lies the planet's most defining and most unusual feature. Just take a look at this breakdown. Mercury has this massive, dense iron core that makes up about 75% of the planet's entire diameter. To put that in perspective, Earth's core is closer to 50%. So Mercury is basically a giant metal ball with just a thin, rocky coating on the outside.
Wow, that is a huge disproportion. It feels like something really dramatic must have happened in its past. So why is the core so big compared to the rest of the planet? I mean, was it just born that way, or did something happen to its outer layers? That is the million-dollar question, and scientists are still very much debating it. Right now, there are two main ideas. The first one is that a really young Mercury got smashed by a giant object that just blasted away most of its original rocky mantle.
The other theory suggests that because Mercury formed so close to the hot young sun, maybe the lighter rocky stuff was just vaporized or never even got a chance to clump together, leaving mostly the heavy iron behind. We just don't have the final answer yet.
So, all these strange facts we're talking about, the super long days, the giant core, those mysterious hollows, I mean, we didn't figure this stuff out overnight. Our understanding of Mercury was built up piece by piece over a really long time.
You know, for most of human history, Mercury was just that fleeting little point of light in the sky. Our whole perspective completely changed in the 1970s when the Mariner 10 spacecraft did a flyby. It sent back the first ever close-up pictures, and suddenly we saw this cratered world that looked, well, a lot like our own moon. But it wasn't until 2011 that the Messenger spacecraft became the first to actually orbit Mercury, and that mission, it was a total game changer. It mapped the entire planet, it confirmed the water ice, and it's the mission that discovered those hollows. And the story is still going. Right now, the Bepi-Colombo mission is on its long journey there to build on everything we've learned and hopefully solve even more of these puzzles. Okay, this is all fascinating stuff, but it really brings up the big question, right? Mercury is this small, faraway, super harsh world. So why do we spend all this time and money studying it? I mean, what's the takeaway? Why does it matter to us all the way back here on Earth?
That is a great question, and there are really three big answers. First off, Mercury is like a natural laboratory for extremes. It shows us exactly what happens to a planet living right up next to its star, and that helps us understand the thousands of exoplanets we're finding out there in similar orbits around their stars. Second, it's a clue to our own past. If we can solve the mystery of that giant core, it could completely rewrite our theories on how all the rocky planets, including Earth, even formed in the first place. And finally, it's a test for our technology. Building a spacecraft that can survive that kind of heat and radiation, it just pushes our engineering to the absolute limit, and we develop skills that we're definitely going to need for future space exploration.
So, I guess if there's one big idea to take away from our whole tour today, it's this. Mercury might be the smallest planet in our solar system, but it is absolutely packed with complex questions and giant secrets. Small does not mean simple.
So the next time you're outside at dusk or maybe at dawn and you see that fast, bright dot low on the horizon, just take a second and remember what's really there. It's a world where a day is twice as long as a year, a world of fire and ice, and a world with a giant iron heart, just waiting for us to uncover the rest of its secrets.
What a fascinating and strange place. Thanks for taking us there, Alex.
And thank you all for joining us on Deep Signal.